Hello, we're on 6.03 for Algebra 2 today, and we're going to be talking about complex fractions. So I want to take a moment and look at that chart from last class right here. So last time we talked about rational expressions. So that's when you're adding and subtracting, but you do not have an equal sign. That's when you're going to do what you need over what you need, so a form of 1. Now today we're going to talk about complex fractions, which means you just have fractions inside of a fraction. So anytime you have fractions inside of a fraction, you're going to be doing multiplying through by your LCD over 1. Okay, so find your LCD of everything and multiply through by 1. All right, so complex fractions are fractions inside of fractions. Sorry, Mrs. Locke just popped in. So complex fractions are fractions inside of a fraction. So a fraction in which the numerator and or the denominator contains a fraction. Now, we've talked about our negative exponents before. So negative exponents really are just fractions. So it could be a fraction or a negative exponent. If it's a negative exponent, remember you take the reciprocal and that becomes a fraction. So that's what a complex fraction is. Fractions inside of fractions. First one, 1 minus x to the negative first divided by x to the negative second minus 1. So first of all, I do see negative exponents here. So first thing I'm going to do is rewrite with positive exponents. Uh-oh, I think my pen is dying. All right, so we rewrite it with positive exponents, and you're going to rewrite it so everything is a fraction. So write every term as a fraction. So even if, like here, you have a 1, I want to rewrite that as 1 over 1. So put your whole numbers as fractions too. Minus x to the negative first. So think of that as over 1, and then it's a negative exponent, so it's going to flip, and it would become 1 over x to the positive 1, which we don't need to write. Here, x to the negative second with a negative exponent. It's in the numerator and it's negative, so it's going to go to the denominator. There's nothing left in the numerator, so that is a 1. And that becomes 1 over x to the positive second minus 1 over 1. So I'll make that into a fraction as well. So every single term, all 4 of these, should become fractions. So now you can clearly see we have fractions inside of a fraction. So now step 2, I want you to find the LCD of all the terms. Meaning we're looking at this denominator. I'm going to circle in pink all the denominators I'm looking at. This one, this one, this one, and this one. Every single denominator. And I want to find the LCD of all of those. So first look at your numbers. I have a 1 and a 1. The LCD of those would just be 1. And then I have an x and an x squared. So you always want to take the highest exponent there. So that would be x squared. So our LCD will just be 1x squared or simply x squared. Now that you have your LCD, you're going to multiply every single term by that LCD over 1. So multiply every term by LCD over 1. Now this should clear out all of your fractions. If it does not eventually, then you didn't choose the common denominator. So I'm going to rewrite the original. 1 over 1 minus 1 over x, 1 over x squared minus 1 over 1. Now in pink, I'm going to take my LCD, which was x squared. I'm going to multiply every single term by x squared over 1. If you don't have another color and you want to show this, you can show it in brackets too. So every single term gets, I'll put it in the brackets too, gets that x squared over 1. All right, so now what we're going to do is cross reduce. So you're looking along the diagonal since we're multiplying. You're not cross multiplying. That's only if you have an equal sign in between. We're cross reducing. So if I look along the diagonals, there's really nothing to reduce on this one. Then I look over here. I see an x and an x squared. So I have more x's in the top, just one more. So that's going to become an x. I look down here. Along this diagonal, I have x squared and x squared. The ones cancel as well, but they just cancel to 1, so that's why I'm not crossing them off. And here, there's nothing to cancel out either. So do a quick check and make sure that every single denominator that you have is either a 1 or is crossed off. So 1, 1, crossed off 1, 1, crossed off 1, 1. That means we've just gotten rid of all of the denominators. So now we're going to have just a single fraction. So now I have left x squared over 1 times 1 over 1 would give me x squared. Now I no longer want you to write it with the denominator, just the numerators. And here we have left just 1 times x, which would give us an x. Here, everything canceled out here, so you're just left with a 1. Make sure when everything cancels, you don't not write it or write a 0, because they all divide out to give you a 1. They don't cancel out to give you a 0. And then minus here, we have left x squared. So we're getting there. Now we have just a single fraction. And once that we've cleared it out, so here's where we cleared out. And then the last step will be to factor if possible and cancel. So here I'm going to factor x squared minus x. So I see I have a GCF of x, factor out my x, leaving me with x minus 1. And 1 minus x squared is a difference of 2 squares. So I take the square root of 1, which is 1, the square root of x squared, which is x, 1 plus, 1 minus. And now I want to look to see if there's anything I can cancel. There's only one x up here, no single x's or x to any power down here. But I do have an x minus 1 up here and a 1 minus x. So the exact same numbers, but in the wrong order with subtraction. So whenever that happens, I cancel them out and replace the top one with a negative 1. Now what do I have left? X times negative 1 is negative x over 1 plus x would be your final answer there. So you're just reducing these. You're not solving for x. There's no equal sign. We're just trying to reduce it and get rid of the fractions inside of the fraction. Okay, let's try another one. I think these are really fun, but I know that they are often challenging for students because you've got a lot going on here and a lot to remember. The hardest part about the stuff that we're doing, I think, in this unit is when you look at it all together, just deciding what method to use. So really important to look and say, all right, first of all, I have fractions inside of a fraction. That's a complex fraction, which means I need to multiply by the LCD over 1. Instead of, like last class, when we were adding and subtracting, if we had something like just this, that would be when you would get a common denominator by multiplying what it needs over what it needs, so a form of 1. All right, so everything is already written as a fraction, every single term. All 3 fractions are written as fractions. So now I need to find my LCD. So look at all 3 denominators again. So we've got x plus 1, and x. So I'm looking at x plus 1, and x plus 1 to find my LCD. Remember, we talked about binomials are a nice little gift. Each one is a package. It cannot be separated. So even though this x is also an x plus 1, you have to include that separately. So we would include x and x plus 1. Since x plus 1 is written twice, we only have to include it once in our common denominator. All right. Okay. So now we're going to, excuse me, I sneezed. Now we're going to take our LCD, x times the quantity x plus 1, and we're going to multiply every single term by that LCD over 1. So I'm going to take x times x plus 1 over 1. Every single fraction inside of our big fraction must be multiplied by that LCD over 1. Now, once I do that, now I can cancel out. So I'll go along my diagonals here. So x plus 1 will cancel with x plus 1. Look at the next set that's being multiplied. Here the x will cancel with the x. Here my x plus 1 with my x plus 1. Do a quick check. Is every denominator either a 1 or crossed off? Yes, which means we've gotten rid of all of those denominators. So now we should have just one big fraction. So let's write what we have left here. So on the top, I have 20 and an x, so 20x. In the denominator, I have x plus 1 times 1, which just gives me x plus 1, minus, and then I'm left with just 7x. If that was a binomial left over here, you would want to make sure you distribute that negative. So if you put that in parentheses, that might help you to remember that, to always put it in parentheses. But you don't have to have the parentheses there. All right, so now I can combine my like terms in the denominator. So I have a 1x minus 7x. So that'll give me negative 6x plus 1. Now, the question is, can I cancel out these x's right here? And the answer is no, because this 6x right here, this negative 6x, is attached to something with addition. It cannot be canceled with a single x. So you cannot cancel them out if it's attached to addition. If this was negative 6x plus 1 up here, that whole binomial being multiplied by 20x, then you could cancel out the whole binomials. But you can't separate parts of your binomial to cancel with parts on the top. Okay, so this is actually, there's nothing to factor. So that is your answer. That's as far as you can go. Let's try the next one. So 1 over a minus 1 over a plus 2 divided by 1 plus 1 over a squared plus a minus 2. All right, so the first thing I would do on this one is, of course, make everything into a fraction. So I just see this 1 right here is not written as a fraction, so I'm going to put that over 1. The next thing that we have to do on this one, which we haven't had to do before, is looking at my denominators. This one right here can be factored. So you want to make sure you factor any denominators first that can be factored. If you need to go off to the side and do it over here and use P's and C's, that's fine. Or if you're comfortable going straight to guess and check, we'll do that here. So we've got a times a is a squared. What multiplies to negative 2 and adds to 1? That would be positive 2 and negative 1. All right, so let me rewrite this here. So I've got 1 over a minus 1 over a plus 2 divided by 1 over 1 plus 1 over a plus 2, a minus 1. Now let's talk about our LCD. So we're looking at all 4 of our denominators here, and we need to find our common denominator. So I have a 1. That's the only number I have that's out in front. And then I have an a minus 1 and an a plus 2, a minus 1, a plus 2. So remember, all of your binomials have to be, they can't be separated, and you have to include all of them. But if they're repeated, you only have to include them once. Pause the video here, see if you can write down your LCD, and see if you can finish it and multiply through and cancel out and see what you're left with. All right, so you should have gotten a minus 1 times a plus 2 for your LCD. Now I'm going to take that and multiply every single term by my LCD over 1. Again, you can use those brackets. I'm using another color. Sometimes that just helps to separate them. So I multiply every single fraction, including this 1 over here. This tends to be one of the most common mistakes, is that students forget about this fraction. They don't multiply that by your a minus 1, a plus 2. All right, so now let's go through it and cancel. So here we've got a minus 1 cancels, a plus 2 cancels. Here both of them cancel, and here nothing cancels. So go through, check your denominators. Is every single denominator either canceled out or a 1? And yes, it is. So now we can write this as one big fraction. So the first one I have left is 1 times a plus 2 minus. Now here I'm subtracting a binomial. So important to put that in parentheses because I'm subtracting both the a and the minus 1. Here I'm left with a minus 1, a plus 2, plus everything canceled out here. So make sure it doesn't go away. It still stays. It's just a 1. Now we have some simplifying to do. So in our numerator here, I've got to distribute my negative. So you can just change that to a plus and change everything after it, if that's easiest for you. Or you can rewrite it. Maybe I'll do both here. So a plus 2, then we're going to have minus a plus 1. Now here, to combine our denominator, I'm going to need to FOIL this because I have a binomial times a binomial. So pause here, go ahead and FOIL that out. So you should have gotten a squared plus a minus 2. And then I still have that plus 1 that I'm bringing along. Let's continue to combine our like terms. A minus a cancels. 2 plus 1 gives me 3. And then in the denominator, I can combine the negative 2 and 1 to get a squared plus a minus 1. And then, of course, you can check to see if you can factor, but if we need to multiply to a 1 and add to a 1, we can't do that, so it's not factorable, so we would just leave our answer just like that. Okay, so a lot going on in that one, a little bit of a longer problem to do there. All right, I want you guys to do a couple practice ones on your own. All right, so the first one I want you to do is 2 over x minus 1 minus 5 over x plus 1 divided by 3 over x squared minus 1. Pause the video and give this one a try. All right, so here are a couple little hints. I won't write it all out, but you should have had, first of all, factored this first to become x minus 1, x plus 1, which should have been your LCD, multiplied everything through by that LCD. Your final answer here should be negative 3x plus 7 over 3. Now, if you did not get that, what I want you to look for is to make sure you distributed your negative here. One thing that might help is to change this to addition and then make the 5 a negative. And then when you multiply through negative 5 times your x minus 1, make sure you distribute that negative. So the numerator would be 2x plus 2 minus 5x plus 5 over 3, and then reduce to that. So you should have all of the work written out for that one in your notes. All right, let's try x to the negative second plus 2 over x to the negative first plus 2 to the negative first. Give this one a try. And when you do this one, first start out by writing everything out as a fraction. All right, so as a fraction, just to review that, you'd have 1 over x squared plus 2 over 1, 1 over x, and then 2 to the negative first become 1 over 2. Your LCD there should have been 2x squared. And your final answer, which I should see all the work to get that, and I'd like your final answer in factored form. It's best to leave it in factored form so you can check to see if you can cancel anything out. All right, and let's throw in another one where you have to do a different process here. Oops, I want that to be minus 1 over x squared plus 6x. Sorry, there we go. So for this one, please make sure you look and see this is a different type of problem. We now have we don't have fractions inside of a fractions. You're adding and subtracting here. So this is like what we did last class. So go ahead, pause the video and try that one. Okay, And your final answer there should be 1 over x times x minus 6. If you don't get that answer, please make sure you see me so that I can help you with that one. All right. And next one, I want you to simplify this one. Again, a different type of problem here, so pay attention to that. Pause the video, try this one. All right, your final answer should be negative 3x. You should have factored each of those and then canceled them. And then the last one, right. Okay, so for this last one here, we had 2 over x plus 4 minus 2 over x. Actually, we're going to make that plus 2 over x divided by 1 plus 3 over x plus 4. So decide what type of problem this is, pause the video, and simplify it. All right, so you should have nothing to factor here, but I would first start by making this into a fraction, so putting that over 1, so everything's a fraction, and then finding your LCD, so looking at all 4 denominators. Now be really careful here when you do that. So you have the 1, you also have an x, and then also an x plus 4. So just x plus 4 would not be enough for your LCD. You also have to include that x. Even though there's an x and x plus 4, it's not a binomial, so it has to be included separately. So then multiply everything through by your LCD over 1. Your final answer should be 4 times the quantity x plus 2 over x times the quantity x plus 7. And again, I'd like that in factored form like I just gave it to you, as opposed to giving me 4x plus 8 over x squared plus 7x. That is correct, but I'd like you guys to get in the habit of factoring it so that you can see if there's anything that you can cancel out. Okay, so again, really pay attention to what type of problem you have and then try to solve it using either need over need if you are adding and subtracting fractions without an equal sign. If you're multiplying or dividing, you're going to do, we'll keep, change, flip, but factor each one and cancel it. If you have fractions inside of a fraction, which is today's, you're going to rewrite everything as a fraction, if it's not already, and then multiply everything through by your LCD over 1. So really important to keep those different methods straight. If you have any questions on any of these, please be sure to let me know. If you couldn't get the same answers as I got on these practice, also let me know and I can help you through that to figure those out. I hope you guys have a great day and pie out.